In this video, I am going to show you how to sketch an angle in standard position, convert radians to degrees, and from degrees to radian. Also, I am going to show you how to find the coterminal angles, how to come up with the reference angles, and then the last thing is to find the exact values of the trig functions given data. Okay, so the first thing here is I am going to show you how to sketch an angle with the given measure in standard position. An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. The ray on the x-axis is called the initial side. The other ray is called the terminal side. Counterclockwise rotations result in positive angle measure. So if you rotate counterclockwise, you have a positive angle. Clockwise rotation result in negative angle. And then one full revolution is 360 degrees. Okay, so this is the initial side right here. So this is your initial side. And then this is your terminal side. Theta is a positive angle because it rotates counterclockwise. Okay, so let's take a look at an example here. It says to sketch an angle with the given measure in standard position. So here we have to sketch an angle that is 430 degrees. Okay, so it's a positive angle. So it's going to rotate counterclockwise. Okay, so starts here. This side right here is going to be your initial side. Okay, and we're going to rotate 360 degrees. Okay, so that's 360. Because it's one full revolution. And then we need to go, okay, 430 minus 360 is 70 degrees. Okay, so these are degrees. All right, so we need to go 70 more degrees. Okay, so we're going to go up here. Okay, because if you go all the way to the y-axis, it's going to make 90 degrees, so it's not there. Okay, so your angle theta is going to be, okay, so this is your angle theta. It's 430 degrees. Okay, so now I'm going to show you guys how to change from radians to degrees, and then from degrees to radian. A radian is a unit of angle measured based on arc length. 1 radian is defined as the measures of the angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2r pi, 2 times radius times pi. Therefore, 360 degrees is the same as 2 pi radians. 180 degrees is the same as pi radians. So converting degrees to radians, okay, you take the degrees, the given degree, and you're going to times it by pi radians over 180. And then to go from radians to degrees, you take the given radians and you times it by 180 over pi radians. Okay, so let's take a look at this example. It says to convert each measure to radians. So you're given 150 degrees. So if you go back and look at the formula to go from degree to radian, you're going to take the given degree, okay, and you're going to times it by pi over 180. Okay, so here we're going to take 150 degree, okay, and then we're going to times it by pi over 180 degree. Okay, so multiply here, you're going to get 150 pi all over 180. And then we're going to reduce it. Okay, we can take out the 0 here, and then greatest common factor for 15 and 18 is going to be 3. So you divide both numbers by 3. So 15 over 3 is 5. So this is 5 pi. And then 18 over 3 is 6. Okay, so the radian measure for 150 degree is 5 pi over 6. Let's take a look at the next example. So this one is to go from radian to degrees. Okay, so you're given the radian measure of an angle and you want to change it to degree. So you're going to take 5 negative 5 pi over 36, and you're going to multiply that with 180 over pi this time. Okay, and then here you can cross cancel the pi. Okay, so here I can divide this by 6 to get 6, and then I divide this by 6 to get 30. And it looks like 6 can go into 35 times, so we can still cross that out and make this a 5. Okay, so multiply and cross now, you are going to end up with negative 25 degree. Okay, so negative 5 pi over 36 is the same as negative 25 degree. So next I am going to show you guys how to find coterminal angles. Okay, so angle in standard position with the same terminal side, those are coterminal angles. They have the same terminal side. So here we want to find two coterminal angles for each given angle, one positive and one negative. Okay, so they have the same terminal side, so that means it's going to change by 360 degrees. So for example, okay, so let's say I have this angle right here, for example. Okay, let's say I have this angle here. Okay, so terminal angle would be another angle that's going to change by 360. So you got to go around and all the way back. Okay, so that would be adding 360 to it. And then the negative angle would end up going this way. So you start here and then you go all the way here to the same terminal side. Okay, so that is a change by 360 degrees. So you minus 360 to get that angle. Okay, so here we're working with 540 degrees. So to get the positive coterminal, you would want to add 360. Okay, but according to this, because it's 540, okay, so if you minus 360, okay, you are going to end up with a positive number. So you can also minus 360 to the 540 to get the positive answer to it. So here if I add 360, okay, I'm going to end up with 900 degrees. So 900 degrees is the coterminal angle of 540 degrees. Now, so if I take 540 degrees and then I minus 360, so this is going to end up with 180 degrees. Okay, so 180 degrees is coterminal angle of 540, and it's the positive. So here I found 2 instead of 1. Now to get the negative, I would have to minus 360 2 times. Because if I minus 360 1 time, I end up with a positive number. Okay, so here I would have to take 540 degrees minus 360 degrees That's going to give me 180 degree. And then I have to minus 360 again, because I need it to end up with the same terminal side. So here it's going to give me negative 180 degree. Okay, so here I found the negative coterminal angle and then the positive coterminal angle. And you can also use this one. Okay, so that is how you find coterminal angle. Okay, add 360 or minus 360. And sometimes you have to keep going because you want to end up with the right number. Okay, so let's take a look at the next example here. So here we'll give it in terms of radian. So here we need to find a positive coterminal angle and a negative coterminal angle. So I'm going to go ahead and add 2 pi here to come up with the positive. Okay, so in order to add, I need common denominator. Okay, so I would have to get both denominators to a 9. So times this by 9, times this by 9. So I got 14 pi over 9 plus 18 pi over 9. Now I can add. Okay, so adding these two numbers, I end up with 32 pi all over 9. Okay, so this is the positive coterminal angle for 14 pi over 9. Okay, so now I'm going to try to minus 2 pi. See if I can come up with the negative number. So 14 pi over 9. So here we're going to minus 18 pi over 9, right? Which is the same as 2 pi. So minusing these two numbers, you end up with negative 4 pi over 9. Okay, so there is the negative coterminal angle for the 14 pi over 9. Okay, so that is how you come up with the coterminal angles. Okay, so now I am going to show you guys how to find the reference angles. If you look at the diagram here, okay, so angle theta, so here as you can see angle theta, the reference angle is this angle right here, the shaded angle. Okay, so for an angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. So here's the terminal side, here's the x-axis. As you can see, it's the acute angle that is formed by the terminal side and the x-axis. So we're going to look at examples of how to come up with the reference angle. So with the example coming up, we are going to sketch and find the reference angles for each angle. So let's take a look at this example here. So here you have theta that is negative 310 degree. Okay, so we are going to sketch this angle negative 310 degree. And then we are going to come up with the reference angle. To sketch the angle, we are going to start right here with the initial side. So here's the initial side. Okay, so negative, it's going to rotate clockwise. So here's negative 90, negative 180, negative 270, and then you gotta go 40 more degree to get that negative 310 degree. So it's gonna be something like that. Okay, so this is negative 310 degree. Okay, now the reference angle is this angle right here. It's the terminal side with the x-axis. So how do we come up with this acute reference angle? Well, if you go all the way to the x-axis, it's going to be 360 degree, right? Okay, so the reference angle here is going to be 50 degree because 310 plus 50 is going to be 360 degree. Okay, if you rotate one revolution, so if you rotate one revolution, right? That's 360 degree. Okay, so if you take 360 degree minus 310, okay, that's how you come up with the 50 degree. The last thing here is I'm going to show you guys how to come up with the exact values of the trig functions given a point on the terminal size of theta in standard form. So here you're given point P that is at 5, -2 on the terminal size of theta in standard form. Find the exact values of the trig functions of theta. So we have to come up with these 6 trig functions. Okay, so first thing I'm going to do here is to graph the point 5, -2. Okay, so here's your x-axis, here's your y-axis. So 5, -2, so that means 5 to the right, 1, 2, 3, 4, 5, and then -2 down. So 5, -2 is right here. So that's point P. Okay, so that point is on the terminal side. Here is the terminal side. Okay, so this is the angle that we're going to be working with, the reference angle. Okay, so here's the angle you're going to be working with. Okay, so there you have a right triangle. So this is going to be 5. Okay, and then here is going to be -2. So this here is going to be 2. Okay, and then now we have to find the hypotenuse to come up with the ratios of these 6 trig functions. Theta is here. Okay, so to come up with the hypotenuse, you have to use the Pythagorean theorem. So that is a squared plus b squared is c squared. Okay, so a is going to be 2. So here's going to be 2 squared plus 5 squared. And then your hypotenuse, that's what we're looking for. So that's going to be c squared. So here we have 4 plus 25 is c squared. So 29 is c squared, and then we take the square root of it, and then square root of 29. So c is going to be square root of 29, okay, which is not a perfect square, and we cannot simplify it. Okay, so the hypotenuse here is going to be square root of 29. Okay, so now you have all 3 sides. Therefore, you can find these 6 trig functions. And we're going to use the phrase that help us to remember the ratios of these 6 trig functions. So that's SOHCAHTOA. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Okay, so sine is going to be 2 over square root of 29. Okay, you got to rationalize. So it'll be 2 square root of 29 all over 29. Okay, and then cosecant is the reciprocal of sine, so you're just going to flip it. So this one would be square root of 29 all over 2. Moving on to cosine. Cosine is adjacent over hypotenuse, so that would be 5 over square root of 29. So 5 square root of 29 over 29 after you rationalize. And then secant is the reciprocal of cosine. So this is going to be square root of 29 over 5. Okay, you just flip it. Tangent is opposite over adjacent, so that's going to be 2 over 5. And then cotangent is the reciprocal of tangent, so that would be 5 over 2. Now that we found all 6 trig functions, now we have to fix the signs of these 6 trig functions. Okay, because some of these are going to be negative of this -2, right guys? Remember this 2, it's a -2. Okay, so this is going to be negative right here. So this answer here is going to be negative. So that means this is going to be negative. So here you have positive, positive. So this is positive. Okay, so we don't have any negative here. So the answer of this one is positive. And then the answer to this one is negative. The triangle is in the fourth quadrant, and the only two trig functions that are positive in the fourth quadrant is cosine and secant. Alright, so this is how you come up with the exact values of the trig function given a point that is on the terminal size of theta in standard form.